लैब में बैठा डेढ़ घंटे Right, Bismillahirrahmanirrahim. Welcome to the second lecture on mathematics for machine learning. Last time हमने क्या देखा है, किस बारे में डिस्कस किया है, कुछ याद है? करीब करीब यह लेक्चर
मशीन कैसे लर्न करती है, जैसे आपने हमें वो क्रोकोडाइल और उसके एग्जांपल दिए,
मशीन लर्निंग और एआई की डिफरेंस थोड़ा सा डिस्कस किया था हम लोगों ने,
इंटेलिजेंस और लर्निंग के बीच. So we discussed the main idea of the course, we motivated the applications of the course, the needs of the course, and then we went on to talk a bit about how learning occurs in organisms, right? In that we saw for the brain, of course, where the units are neurons, and then we also saw that this idea wasn't limited to the brain. There are species, organisms, groups of organisms that can also say perform such complex tasks. Yeah. So key idea क्या था जो रेड में मैंने काफ़ी दफ़ा लिखा? It was repetitions of rather simple units with rather simple rules. Yeah. So that was kind of the underlying discussion. In terms of brain, although physiologically that's what we see, पर अभी तक हमें इतना क्लियर नहीं है कि ब्रेन एग्जैक्टली इतना एफिशिएंटली कैसे काम करता है. सो देयर माइट बी सम हायर रूल्स देयर दैट वी डोंट नो येट. जो आप कल पूछ रहे थे ना, हो सकता है वंस दे आर डिस्कवर्ड, सो वी गो टू वन फर्दर हायर लेवल ऑफ computation and consciousness. The way the brain actually works is still an open question. There is no definition of consciousness, the ability to know that we exist. Yeah, वो चीज़ें सारी is not very clear. But in any case, this physiological understanding of the brain, where we time and again see that there are simple units interconnected with simple rules. Yeah, and when we copied that onto mathematical modeling and computation, it started to pay off great dividends. So it started to perform really well. So that's where we are at the moment. Yeah. So today we will continue our journey in the magic part, but this time we will talk about magic or the magic of learning in algorithms. पिछला organisms था, natural, yes. Now we are going to algorithms, which will be artificial, machine, whatever you want to call it. Yeah, mathematical. So let's start with that. Is what we saw. So first, maybe I should give you a chance to say, how do you think machines learn? आपका क्या ख्याल है? अंदर क्या हो रहा होता है, मतलब वैसे तो आपको पता है क्या? So what is going on in there to help them learn? किसी का कोई general? I just want to know कि where you are at the moment.
सर हम उसे ट्रेन करते हैं मशीन को,
ट्रेन करते हैं,
प्रोग्राम डालते हैं, मशीन को ट्रेन करते हैं कि आपने ये काम करना होगा.
सो ट्रेन कौन हो रहा है उसमें?
एल्गोरिथम बेसिकली हम लोग आइटरेशन जो उसमें परफॉर्म करते हैं, डिफरेंट किस्म के जो रूल्स यूज़ करते हुए वो हमारी जो कमांड्स हैं उनको यूटिलाइज कर रही होती हैं और उन्हीं के मुताबिक वो हम एक्शन परफॉर्म करते हैं मशीन.
Sir, actually we train an algorithm because in every machine learning program there is always an algorithm that learns with different learning rates. So actually we train an algorithm.
So when you say an algorithm is learning, तो थोड़ा सा और आगे जा सकते हैं कोई? It's fine if you can.
set of formulas on different values.
Values, formulas, links के weights हो गए. Yeah. So in general there are some models inside. और हम what are we doing? We are trying to perfect their parameters. Right? So model है कोई, कोई मैथमेटिकल मॉडल जहन में आता है आपके बेसिक वैसे कई पढ़े होंगे आपने, राइट? लीनियर मॉडल y इज इक्वल टू mx प्लस c, लाइन की इक्वेशन है, इट्स अ मॉडल, इट मॉडल्स ए जियोमेट्रिक ऑब्जेक्ट विच इज ए line passing through c, yes, with a slope m. So if you were trying to learn m and c, yeah, so you could predict what y would be for another x, yes. So in the end it just comes down to parameter estimation. Estimation theory is not new, yeah. So what's the magical thing in machine learning that it's become so powerful? Yeah, so वो आज हम थोड़ा बहुत उस पर भी बात करेंगे. This was just to get you started. By the way, it's my style. I ask a lot of questions during my lectures. I see the lecture as more of a conversation. Yes, so it's also pedagogically very good because if I throw information at you, you may be partially receptive to that. But if I first ask you and then let you wander a bit, look down for a while, avoid eye contact, yes, or maybe you're thinking really deep and you come up with answers. Some of them may be correct, some of them might be partially correct, some of them may be totally wrong. It's perfectly fine. This is not to test you here. Yeah, uska time aayega. Yes, this is not the time. So at this time the questions are more of a conversation. They prep your brain to receive the answer. और अगर आप खुद वहाँ तक पहुँच जाएं बहुत अच्छी बात है, right? But of course that's not required because of course you are still learning this topic. So well, they mostly learn algorithmically, as you guys said, and again going deeper that we will look at today also a bit what that means. Now here's a question. There is a joke in English language called why did the chicken cross the road? सुना हुआ आपने? नहीं सुना? ये बड़ा इंटरेस्टिंग सा जोक है क्योंकि इसके जवाब बड़े मुख्तलिफ मिलते हैं. सवाल इतना ही है बस, Why did the chicken cross the road? So क्या ख्याल है आप? इसका कोई ताल्लुक नहीं कोर्स से. ओके, देखिए नए जवाब आ रहे हैं. और Why did the chicken cross the road? बिल्कुल आउट ऑफ द बॉक्स भी आप सोच सकते हैं, कोई मसला नहीं. कोई कहते हैं कि उसको उड़ना नहीं आता. क्या कहते हैं?
रोड की वेट ज़्यादा होती है,
वेट ज़्यादा होती है. अच्छा, इसका जो प्रॉपर आंसर समझा जाता है ना, विच इज़ द पंच लाइन, इज टू गेट टू द अदर साइड. दैट्स व्हाई एनीबॉडी क्रॉसेस द रोड. और किस लिए करते हैं? शौक होता. टू गेट टू द अदर साइड. या सो एनीवे, व्हाई डिड द रोबोट क्रॉस द रोड? Now, at higher level, machines, as I said, they learn mostly algorithmically. Now, the algorithm itself does not say what level of abstraction we are talking about. Yeah. So, on a higher level, the algorithms are mostly logical. Logical क्या होता है? अगर ये है तो ऐसे है. If it is Tuesday, don't go to my lecture. Yes, there is no lecture. If it is Saturday, there is a lecture. So if then else for वगैरह, this is logic. Yeah. So on a higher level, most of the learning is algorithmic. You tell the robot, okay, if you see a bike, cross at normal speed. If you see a motorbike, cross a bit faster. Yeah. There is a zebra crossing, they will not hit the robot anyway, but it's nice to not make them wait too much. Yes, that's all. So this is a higher level thing, and that is fine. You can have learning at a high level, but at a deeper level, it's mostly mathematical. Now logic is also, by the way, a branch of mathematics, but when we say mathematically, we mean more in terms of quantifiable things, numbers, vectors, yeah, matrices, spaces, groups, all that. So there, as I asked you before, how can an algorithm teach a machine? Yeah. So there is a machine learning algorithm which is teaching some machine to do something. So a secondary question here is, just like we saw in organisms and in the brain and in the different ant colonies, We saw simple repeated units led to rules and units led to complex tasks being done. So can we do that here as well or not? So I give you this very difficult problem, deciding to apply for a leave to go to Murray or not. Yes? Any of you into literature? Shakespeare पढ़ा किसने? पढ़ा वो. To be or not to be? That is the question. Yeah. So to marry or not to marry? Let's see. Let's say you have a friend Ali. अब यहाँ कोई बैठा हुआ है तो मेरा कसूर नहीं है, ये लेक्चर आपके ज्वाइन करने से पहले लिखा गया, ठीक है? So let's say you have a friend Ali, and Ali says to you, चलो यार मरी चलते हैं, let's go to Murray. ठीक? आपको पता है कि अली इतना, ये जो बात है itself, let's go to Murray, कोई इतनी है नहीं, दोस्त अक्सर कहते रहते हैं, यूजुअली you don't end up going, yeah? चलो यार कागान चलते हैं, फिर होता कुछ नहीं है. Everybody knows that, right?
Yes.
So you know that this statement by itself is more of a habit. गर्मी लगती है कि चलो यार मरी चलते हैं, let's go to Murray. So Ali says let's go to Murray. You assign a weight to this. You say, well, इतनी strong बात नहीं है, yeah? Now on top of that, you know that Ali is particularly unreliable. ऐसे ही छोड़ता रहता है, बैठे बैठे यार चलो वहाँ चलते, जाना उससे नहीं होता, सही. So what you do is you decide कि भाई अली, ये बात खुद भी हल्की सी है और ऊपर से अली खुद भी काफ़ी unreliable है, तो you give him further low weight. Now your decision is whether to apply for a leave. कहीं जॉब करते हैं आप, कहीं काम करते हैं, कुछ यूनिवर्सिटी में है. You want to set some sort of threshold. When it's crossed, you want to apply for a leave, right? Before that, you don't want to do that. Now you're doing it algorithmically. ये कोई normal इंसान ऐसे करता नहीं है. ठीक है, it's just to show you the idea. Now let's say you have set an activation function. You decide that if the input, that means at this stage the input for this guy means here. Yeah. यहाँ जो value है question mark की जगह, if that value exceeds 0.3, I will apply for a leave. Because then most likely we are going to marry. Yeah. Now you have another friend Taj, and Taj says the same thing. Again, बात तो वही है, हल्की है. But you know, Taj is a very serious guy. ऐसे ही नहीं मारता वो. Usually he is serious when he says something, mostly. So Taj gets more weight, 0.7. Yes. Is your threshold crossed? किसका mental math अच्छा है?
क्रॉस है,
आपकी वो थ्रेशोल्ड क्रॉस होगी है कि नहीं?
क्रॉस होगी, 0.7 होगा कि श्योर.
अरे 0.7 टाइम्स 0.1 जाएगा ना उधर समेशन, और 0.1 टाइम्स 0.1 जाएगा, राइट? सम होगा ना. सो 0.1 टाइम्स 0.7 प्लस 0.1 times 0.1. Yes, so it's not crossed yet. Now let's say there is another marker. If a friend of yours says I applied for a leave, now if Ali says it, this is a slightly more serious matter. Yes, आप इसको थोड़ा और वेट ज़्यादा देना चाहते हैं compared to let's go to Murray. सब कहते रहते हैं. अब वो कह रहा है I've applied for a leave, but still it's Ali, so 0.3 will be multiplied by 0.1 क्योंकि अली की बातें बहरहाल होता है ना, एक अली सबका दोस्त होता है. So but if Taj says it, yeah, अब कैलकुलेट करके देखिए. So it crosses your threshold now. Okay, so together this whole thing gives you maybe 0.32 or something. Yeah. So this crosses your threshold, and you say, okay, now I think I should apply for a leave. Yeah. So what you have done is develop an algorithm based on simple rules and simple calculations. कोई integrals तो नहीं लगाए मैंने इधर, या कोई बड़ी कोई चीज़ें नहीं लगाई. या simple rules, simple units. You could in fact replicate these simple components and simple rules maybe आपके बहुत सारे फ्रेंड्स हैं और भी बातें वो इस तरह की करते हैं, मिला जुला के मे बी यू वांट टू make something happier, you could replicate those rules. Yeah, मरी के लिए ना करना, पर basically we do it for a lot of things now, insurance claims वगैरह के लिए. Yeah, how do companies apply machine learning to decide if the insurance claim might be fraudulent, fraud है इसमें. Yeah, so they have different kinds of markers, and the markers have their features, their weights, and the person's history also has its weights. पहले इसने कोशिश की, कितनी दफ़ा ले चुका है, एक ही मोबाइल कितनी दफ़ा तोड़ चुका है इंश्योरेंस के लिए, राइट. सो they can assign those and then raise a flag. Okay, maybe this case needs looking into. Maybe there's some fraudulent behavior. So you could create copies, replications of those simple rules. Now this is happening mathematically. Yes. Now, what does this remind you of, by the way? पिछले लेक्चर से क्या चीज याद आती है इसको लेके? वो तो हो गया, वेरी गुड. और क्या? न्यूरॉन. याद है न्यूरॉन क्या कर रहा था? ऐसा नहीं है कि as soon as it receives let's go to मरी, अली ने कहा और वो गया छुट्टी अप्लाई करने. ऐसा तो नहीं होता. थ्रेश होल्डिंग करता है. यस. When the potential on it coming from different neighbors, neuron neighbors, reaches a certain level, then it says to the next guy, okay, let's do something. Yeah, then it sends a proper signal. Yeah. So essentially, this is what's happening. First, this came in, no action, and more of this came in, no action. But then, when the total weight of all what they were saying crossed a certain limit, you were able to decide, okay, I need to take an action. Yeah. Maybe that action might not be applied for a leave. It might be telling another friend, let's go to Murray. Right? हो सकता है आप ग्रुप बनाना हो कोई. So it's not necessary that that should stop here. So what you can have more layers in there. Yeah? Like the real neurons. कितने बताए थे मैंने ब्रेन में? 100 billion with more than 100 trillion connections. ये तो कुछ भी नहीं है अभी. Yeah? So now this is far more interesting than what I have shown you already. You may want to do this in reverse. Yes? What is that? You may say, okay, I have data, somehow आप बड़े ध्यान रखते हैं, सारा कुछ नोट किया हुआ है. Now an insurance company would have the data. Yes, but for money decision it's not so special. But anyway, let's say you have the data. The last time Taj said, let's go to Murray, we call it 1 here. Ali says, let's go to Murray, Taj said. So you may have different values here, 0, 0, 1, 0, 1, 1, 0, 1. That this one means, 0 means that Taj hadn't said this, but the other 3 happened. Yeah. So this is historic data. And if you have also historic data on when this happened, did we end up going to Murray or not? Yeah. And you may want to say, okay, now I want to assign those weights based on what they did and what happened in the end. So these are pairs now. What they said or did not say, and did we end up going to Murray or not? Long history आपके पास. If you can assign these weights here. Now the process of assigning these weights is learning. So the question मैंने आपसे पूछा था, how can an algorithm learn? We haven't answered that fully. We have just set up a structure, a mathematical structure for the learning. Of course, there is this question still, and we will learn the answer to that in this course, of course. How can we use this information to set weights and thresholds? But notice the idea is the same. Learning simple rules for simple repeated units to help solve difficult problems. Once you have learned then you apply it, then you use it. Yeah, then you use it in this mode. Once you have learned, फिर आप उनको यहाँ रख देंगे और अगली बार जो वो कहेंगे उसकी बेस पे आपका वो डिसीजन आ जाएगा. But this course, याद है जो using a learned machine is not the object of this course. Okay? वो तो एक बार लर्न कर लेती है, वेट्स हो गए, जस्ट पास द न्यू इनपुट थ्रू एंड गेट द आउटपुट. इट्स जस्ट अ सिंपल फार्मूला, कोई बड़ी बात नहीं. दिस कोर्स इज अबाउट लर्निंग, machine learning. Yes, so we are more into this question and this part, and this is not the only structure we will look at. Yeah, we will look at several different kind of mathematical structures, and then we'll look at several different ways of answering this question. But in essence, it gives you an idea, a mathematical idea of how an algorithm can teach a machine. There is a structure which allows this kind of teaching, and then we will bring in the actual weight update formulas that will help us. Yeah. Now, you could learn rules from input, output, or history of things. So for example, I tell you there is a system, when I give it 2, it gives me 4. I don't care what's inside. When I give it 3, it gives me 6. When I give it 4, it gives me 8. Yeah. So what will it give me if I give it 10? Now your brain is learning. Yes, it's mathematical learning. You do it all the time in your mathematics. So क्या आएगा? 20. So you realize first you learn the rule. आपको नहीं पता 10 का जवाब 20, पहले तो नहीं पता था. Exactly. You learn the rule, and now whatever input I give you, you will apply that rule. Yes. So you learned the rule and applied it, and you gave me 20. So there can be learning from input-output history, input-output data, or it could be just from history of something. आप पास डेटा है, टाइम सीरीज इसको हम कहते हैं, indexed values. Yeah, temperature today, tomorrow, today, yesterday, day before, पूरे महीने के सारे दिनों की. Yeah, we call it time series. I'm showing you these because these are different kind of problems that we will look at in our learning exercises. Yeah. So अगला नंबर बता सकते? 55. Fibonacci sequence. Yes. So this is the Fibonacci sequence. This is how it works. You add the last 2 values. Yeah. What did you do? How did you find 55? एक उसके अंदर आपने एक पैटर्न ढूंढा है. Yeah. Here this is not an input-output pair story. It's a story of time series. History से आपने पैटर्न ढूंढा है. Evolution कैसे हो रही थी सीरीज की. Yeah. You found a pattern in there, and you applied that pattern to the next value, right? And yeah, that is Fibonacci sequence. So just add 34 to 21, you get 55. Right. Now, I just want to show you also the idea of iterative learning that will help us slowly get closer to this question in red. Yeah. So we'll develop some intuitive feeling for that question. Let's see. Let's say you have a system, you have z equals ax plus by. Yes. These are the rules. You have to learn a and b, meaning what? You want to find their values or estimate their values, and we want to do it iteratively. So what is that? We set some simple rules. Okay, what are our simple rules here? We initialize a to 1, b to 1. Again, these are not universal. You could say, okay, why don't I do a0 and b0? Yeah, yes, you can. You could choose different distributions for this. उस पे हम आएंगे. But what I want to emphasize on is solving iteratively with a simple set of rules. So we initialize a to 1, b to 1. After each iteration, either a or b can go up or down by 1. not both. Yeah, ये मैंने इसलिए किया ताकि ये problem doesn't take me all day to solve. Okay, how do I update them? This updating is the learning part. Yeah, so I start with a equals 1. Should I decide I have to go up to a equals 2, or do I have to go down a equals 0, or should I just instead go for b, make it 2 or 0? Yes, that's going to be the update. That is your learning space now. From that space you have to find what's the best course of action. Now best, yes, it is not a quantitative thing. आपके लिए जो बेस्ट है वो है मेरे लिए ना हो. ठीक है, 2 कैंडिडेट्स हैं, उन्होंने इंटरव्यू के लिए अप्लाई किया है, एक पोजीशन है, आपको जॉब मिल गई, बेस्ट हो गया. ठीक है, उसको नहीं मिली, बेस्ट नहीं हुआ. सो बेस्ट इज नॉट समथिंग, सो वी नीड टू क्वांटिफाई इट. And here I have given one quantification. Again, you may say, well, why not this? Why not least square? Why not something else? Yes, but I'm just going to show you something simple. So I say, okay, I will define my criteria for best is those values of A or B that lead to minimizing of this error, which is what the output I want to see and the output I end up seeing. Absolute distance or difference between them. Yeah, so I'm dealing with scalars here. Okay, all of them are scalars. The actual machine learning almost never works with scalars, because scalars के लिए तो अभी आप इसका solution देखेंगे तो simple होगा, analytical solution. Yeah, so we don't need this. It's just to develop the idea. Yeah? We mostly work with very huge vectors and matrices. So इस रो को समझ लें. You are given input output pair, or triplet in this case. What is that I'm saying? When the input was 1 and 2, yani x was 1 and y was 2, the output was 8. Yeah, this is, we are going to call the output here zd, meaning desired z. So we want to adjust the values of these guys so that we get close to the desired. But remember, you may now want to apply all the difficult calculus or algebra, and we want to keep the rules simple, because we know that in the real data when we're going to deal with it, if the rules are not simple, the computations will become impossible. Okay, just like the neuron thing. So now at the current values where we started, A was 1, B was 1, you would get 3. Agreed? Because 1 times 1 plus 2 times 1 is 3. How far are we from the desired? At the very start, we are 5 units away. Now, how many possibilities do you have given these simple rules for adjusting these? Either one step up, one step down, one of them, not both. So you have 4 possibilities. ये जो सिर्फ मैं एक को अलाउ कर रहा हूँ ना, वो इसलिए है कि ये टेबल और बड़ा ना हो जाए, इसमें और कोई लॉजिक नहीं आया, just to keep it simple. So if A goes down and B stays where it is, the error is increased. Not a good choice. उस तरफ मुझे step नहीं करना चाहिए. ठीक? I show you all 4 possibilities. Among these, you choose the one that leads to minimizing of our criteria. In that sense, this red colored triplet is the best. Yes, among these 4. Okay, so अब we update these. यहाँ क्या आएगा? 1 2. Yes, update हो गया. They have been updated. You just learned a little. थोड़ा सा आपने update किया है. You learned mathematically. Now I give you another pair. 5 4. Iterative learning needs data. Yeah. So I give you another pair. 5 4 22. Now you are here at 1 and 2. 5 times whatever that is, I don't know the actual values, but at my values 5 times 1 is plus 4 times 2 will give me 13. This is saying that it should be 22. How far am I from the desired? 9 points. Yeah. Again, I see, should I go up, down? What should I do? Only 4 possibilities. Among the 4 possibilities, the best in terms of agreed upon rule or criteria is the one in red. Yes. So it's saying, okay, then the seems like the value of a should be increased to 2. Now I give you another set. Yeah. Repeat that thing, and you get here. I give you another set. 6, 4, 24. 2, 3, you had reached 2, 3. You realize that this time the error is 0. So you don't need to take any other step at this point. Yes, you have converged to a value that gives you e equals, the error is 0. So at this point you can say that I have already learned this thing. Now in real applications, of course, there are probabilistic errors in there. So you may not converge to 0 exactly or very quickly. It may take a while. We will come to that when we look at different algorithms. But what I want to show you here was this. Firstly, we could have iterative solutions to the problems that you already know. Basically, अगर मैं आपको ये तीनों सेट शुरू में दे देता, yes, तो मुश्किल था, ये तो बड़ा आसान सा simple linear algebraic system of equations बनती हैं, and you can solve it, right? You might say, well, why are we making our job harder? I'll come to that, but interestingly, this was an exhaustive search. Exhaustive search idea है, when you're looking for values, just सारी values डाल के देखे जा रहे हैं एक range में, जो best आ गई वो. It's a naive approach. Yeah, simple है, basic है. It's not very good when the data set becomes large. So can we do something smarter about this? That we will also see during the course. And here I wanted to show you mainly, as you may say, we could have done this directly. आपको मैं 3 sets दे दूँ, just make 3 equations. In fact, you just need 2. Yeah, make 2 equations, solve them, and you'll get A and B. ये सारा करने की ज़रूरत नहीं थी. But again, the idea is to do iteratively with simple rules, and as the problem set gets bigger, yeah, million by million का जब मैट्रिक्स आ जाएगा ना, तो उसका इन्वर्स करते हुए मज़ा आ जाएगा सारे कंप्यूटर्स को, और वो इतना सेंसिटिव हो जाएगा कंप्यूटेशंस पे. इन्वर्स बहुत सेंसिटिव होता है. छोटी छोटी कैलकुलेशनल एरर्स, अप्रॉक्सीमेशंस, truncations will lead to huge errors, right? So we are setting up the groundwork for simple iterative principles that will scale really well. They don't look very nice on small scale. अगर हम relativistic speed पे ना जाएं, physics का कोई था यहाँ पे कुछ थे, yeah. So if we don't go to relativistic speeds, Einstein वाली, so it seems like the theory of relativity is an overkill, right? आप अपनी गाड़ी पे अप्लाई करें, उसको क्या जरूरत है? Yeah. So when that theory comes to our speeds, it looks like यार कोई फायदा नहीं इसका. Yeah. So here also, these rules that we are developing, or the ideas we are developing, they are for the big scale thing. Yeah. Not just big scale, they are also for kind of problems that may not be as nicely posed as this. आपके पास ऐसी प्रॉब्लम्स भी आएंगी जिनका आपको ये नहीं समझ आ रही होगी कि इसका फंक्शन बनना क्या है. ठीक, आई विल गिव यू सम एग्जांपल्स सून. बल्कि ये आगे, इज दिस अ गुड पोएम फॉर दिस कोर्स? आई शोड यू दिस पोएम लास्ट टाइम. इस सवाल का मैथमेटिकली लिख के दिखाए, है ना? इट्स नॉट जस्ट स्केल, it's also about fuzziness, where we are with the help of machine learning today, we are solving problems that we never thought of posing before. क्योंकि जो पुराना मैथ था वो क्या था, कहाँ से शुरू कर what is this? Yeah, so now a machine has already solved this. As I told you, this was generated by generative AI. It's a website, it's not ChatGPT, but it's a generative AI built specifically for poetry. Google करेंगे generative AI for poetry तो वो आपको दे देगा. But the thing is, that had a switch in it. I had asked it to give me this poem for my course on mathematics for machine learning, and there was this that the creativity should be basic, medium, or high level. So I chose high level. Now, an algorithm not only generated this, but was able to tell itself with much surety that this is a high quality poem. Judge कर लिया उसने और निकली है. I can tell you poetically and मेरे जो math की जो बातें इसके अंदर है, this is perfect. I couldn't have expected a better result. और अब it would be hard for me to write this thing. Yeah, but the machine judged it. इस सवाल का जवाब उसने अपने आप को दिया कि this person had asked me for a high quality poem. उसके सिस्टम ने प्रॉब्ली कई जनरेट की होंगी, उनमें से it chose the one it decided is a good poem. इस सवाल का जवाब the machine gave itself. So again, yes, this toy problem, this easy problem, you could have easily solved using very basic linear algebra system of equations. Yes, you could have, but it does that. Those things, as we will see later also in detail, they don't scale well, and then there are problems which don't fit those models very easily. So you might still be thinking, okay, have these led to any amazing results with machine learning kind of repeated methods? And my question again would be really, because these days everybody knows हर रोज ही कुछ आ रहा होता है, AI ने ये कर दिया है. वो जैसे वो नए बच्चे की नहीं तस्वीरें आ रही होती यार उसने वो बैठ गया उठ के हाथ चलना शुरू कर दिया. Right, so AI is all the time in the news now if you read technology news. Yes, even if you don't read it, अब भी कुछ ना कुछ आ ही जाता है. मसनूई ज़हानत ने ये कर दिया, आप क्या कर रहे हैं बैठे. So
चाइना ने हॉस्पिटल बनाई कंप्लीट एआई.
क्या बनाया?
हॉस्पिटल.
अच्छा, पूरा AI पे रन.
काम करेगा सर, कोई भी उसमें नहीं.
वाह,
डॉक्टर्स.
हाँ हाँ,
So
very
they are
good,
replacing doctors also.
very good. So I'll give you a few examples of, last time I showed you some examples of applications of this course. Yeah, so here I want to go a bit farther than that, and I want to talk about, show you some examples of what really amazing things AI has achieved. Yeah, so there is an entire new field coming up called personalized medicine. Okay, now when you go to the doctor, आपको पता है डॉक्टर जो है, हम डॉक्टर से फ्रस्ट्रेट भी हो रहे होते हैं, लेकिन उस बेचारे के पास यही तरीका होता है कि अगर आपको सर दर्द है तो सबसे पहले क्या ट्राई करेगा, जो वो सबके लिए ट्राई करता है. पर्सनलाइज मेडिसिन का ऑप्शन इस वक्त नहीं है, वेस्ट में भी इतना नहीं है. दे आर गोइंग टूवर्ड्स इट नाउ, बिकॉज पहले ऐसा स्ट्रक्चर हमारे पास नहीं था. या फिर आप ये यार इससे तो नहीं गया, फिर वो अगली पे जाएगा, फिर अगली, फिर कोई और टेस्ट लिखेगा, फिर जब वो आखिरी टेस्ट लिखेगा और जो भी मसला पकड़ा जाएगा, आप कहेंगे यार ये तुमने पहले क्यों नहीं लिख दिया. बिकॉज ही हैज़ नो वे टू टेल कि आपका ये स्पेसिफिक मसला उधर तक जा रहा है. यस, तो दैट इज जेनेरिक मेडिसिन. नाउ द फील्ड ऑफ personalized medicine is popping up. Bilal is my batchmate. He graduated from here in 2002 from this program. He was with us last year. He's in GIK's International Advisory Board. He's a senior principal scientist at Genentech. That is called the first biotech company of the world. जब ये खुली थी पहली दफ़ा 25-30 साल पहले, it was called the first biotech company. And his team is working on early detection of cancer. Now, with that, they are trying to use machine learning for personalized medicine. So he gave us an example of one case that he had seen. अब अगर कैंसर की ट्रीटमेंट्स हैं डिफरेंट, या जो आपको मिलती हैं जैसे शौकत खाना में या दुनिया में जो अलाउड है, those are the treatments that have been approved by the government. That doesn't mean कि दूसरी treatments हैं नहीं, right? अब for example अमेरिका की FDA है which approves different treatments and medicines. How does it approve? Yeah. What it does is it goes for generic medicine. What it does is you come up with a treatment for cancer. They say, okay, we will test it on different groups of people and we'll see the side effects and we'll see the efficacy. Yeah. Now, if a certain large number of people get side effects, dangerous side effects, the medicine is discontinued or the treatment is not approved, even though there might be people for whom it was working. Right? So what they found in they saw in one of the cases was that there was a patient who was not responding well to generic treatment, chemotherapy or something. So what was done was the patient's whole data was taken and fed into a machine learning algorithm which had already been trained on not just the approved treatments but the rejected treatments also. And the machine learning said, well, this treatment X is best suited for a patient of this kind of body physiology. All the data from biopsy they had fed in there. But that wasn't approved. And the machine learning was saying, for this guy, that will work. So they got the approval for that particular person, run it on them, and the cancerous cells died. Yeah? Imagine what we could achieve now. This is the power of personalized medicine. Now, it's not just algorithms that have become advanced. In, in the previous run, 20 years ago, when neural networks came up for the second time at least, there was no data to match them. इनको data चाहिए होता है. Now we have that. At least in the West, doctors are sequencing genomes. They are able to sequence the different cells they take from your body, and all that data they're able to feed into a machine learning algorithm, and then that algorithm can decide based on all your genetic information, all the genetic information of the cancerous cell and the healthy cell, your family history, your age, everything, and it is able to compare that to the methods that worked for people whose whole structure and biological details and their cancer details matched with yours. Yeah. So data and that's not just for cancer. Now the idea of personalized medicine is to take a lot of details for the patients, then see what treatment they were given, what were the results, and store that, and train machine learning on that. And now when you will go to a doctor for, at least for more advanced problems, they will be able to collect your data, feed it into a machine, and decide what kind of medicine, what mixture of medicine, what dosage is good for you, or most optimal for you. So for me, this is beyond a standard application. Yes. So this has been enabled by machine learning. Then of course this guy, I think this was the watershed moment. Chat GPT है जो अगर कोई सोया भी हुआ था उसको नहीं पता था कि machine learning और AI कोई बला है. So I think this guy really brought things to public prominence. Machine learning had already started showing up before ChatGPT now. Second इसका arrival शुरू हो चुका था. But it was in decision making, in personalized medicine, it was going there. But to bring it to the public, I think इसने जो कमाल किया ChatGPT ने, yeah? Use किया आपने?
Yes, sir.
किया है? Yeah?
Yes, sir.
Chat किया उसके साथ?
Yes, sir.
डर लगता है? Yeah. I remember when I was here in JIK, 98, a friend of ours sent us via email a small code, and he said this is being distributed by a university in US, and it's a chat bot. It can talk to you. We were very excited, 98. ठीक है। और यू वुड, वही था, छोटा एक सवाल आप करते हैं वो जवाब देता है, या प्रॉम्प्ट करते थे। But after 5, 6, 7 questions, you started realizing, okay, this thing isn't very smart. वो सेम जवाब वो एंड पूछना शुरू कर देता, सेम बातें रिपीट करना शुरू कर देता, मज़ा नहीं आता था। लेकिन अब दिस इज़ ए completely different story. Yes? To give you an idea, I recently tested ChatGPT. मैं इतना यूज़ नहीं किया अभी तक, लेकिन just as a curiosity, I did what I gave it. मेरी अपनी एक गज़ल मैंने इसको दी उर्दू में, ठीक है, and I asked it to translate it into English and explain it. ठीक, तो अब आपकी FSC वगैरह आसान हो गई है, गालिब की गज़ल डालें ठीक है, और हो जाएगी। हो सकता है गालिब की उसको भी समझ ना आए फिलहाल, यू कैन ट्राई, आई थिंक आ जाएगी। बट नोटिस व्हाट इट डिड, ये दीज आर द स्टेंजर्स, शेर हैं लेकिन इसने उनको चार चार, क्योंकि इंग्लिश में चार होते हैं, उस तरह से किया हुआ। लुक एट द ट्रांसलेशन दैट इट हैज डन एंड देन द एक्सप्लेनेशन। या when there are distances in hearts, travel becomes arduous. A home that does not offer shelter is a home that is of no use. इंग्लिश में ना काफ़ी है कि इतनी उनको फिक्र नहीं होती इतनी हमें है ना, इंग्लिश इज मोस्टली ओपन वर्ड्स, या सो इट ट्रांसलेट्स फेथफुली, मीनिंग सही बता रहे हैं, ये मीटर इसका अच्छा है, इंग्लिश के सेंस, पोइट्री सेंस में इट्स वेल रिटन, एंड द एक्सप्लेनेशन इज स्पॉट ऑन। यस, पढ़े आप एक्सप्लेनेशन उसने दी, अभी उर्दू में है, उर्दू का कितने डेटा पे ट्रेन हो गया होगा इंग्लिश का तो लेवल ही हो रहा है। और दिस इज स्टफ डेफिनेटली नॉट सीन बाय चैट जीपीटी इन ट्रेनिंग, बिकॉज ये मेरी अपनी है, ठीक है, इट्स ऑनलाइन, पर आई हैवंट पुट इट देयर विद ट्रांसलेशन और एनीथिंग, सो देयर इज नो वे यू वुड हैव ट्रेन्ड ऑन दैट। या अनोखे साज बजते हैं जिगर जब तार होता है, सो यूनिक मेलोडीज प्ले व्हेन द लिवर बिकम्स अ स्ट्रिंग। इट even mentions, अगर आप पढ़ें, often is the liver often associated with deep emotions in classical literature। कल मैंने जिक्र किया था जिगर का, पहले वो अक्सर, और ये था मतलब ग्रीक फिलोसफी में they didn't think heart or the brain was the special organ, they thought the liver was, है भी, वो जहर निकालता है, टॉक्सिक्स निकालता है ब्लड में से, but anyway then we shifted to heart and then we shifted to the brain, yeah, so
शायद सर उस टाइम वो ऑपरेशन वगैरह तो होते नहीं थे, तो पहली दफ़ा इन साइड यहाँ से ही इंसान को किया गया था ऑपरेट, तो उन्हें लगा कि यहीं से सब कुछ कंट्रोल होता है।
हाँ बिल्कुल हो सकता है, different reasons. So again for me truly amazing example of what the, again ये किसकी example है, repetition of those rather simple rules with rather simple units, yes, units with rules, simple rules leading to this thing. Now just to give you a comparison, अगर चैट जीपीटी से पहले आपने उर्दू का तर्जुमा करना हो किसी चीज़ का, तो किस क्या यूज़ करेंगे, गूगल बुला सकते हैं, गूगल ट्रांसलेट, यस, यूज़ किया कभी?
यस सर।
थोड़ा रफ आइडिया के लिए होता है। दैट इज नाउ गोइंग टू बिफोर दिस थिंग, इसका जरा तर्जुमा उधर राइट पे चैट जीपीटी का है और इसका पढ़े, when the liver is wired, तार लगा दी that guy really, when the liver becomes a string, बचता है ना जिगर जब तार होता है, so a story of pain, so there is good, ये तो अगर कोई छोटा बच्चा बोल रहा है, कोई ताल्लुक नहीं है जुमलों का right, because it said, it thought that it's not पसे अशार, it thought it's पस अशार, पस means so in Urdu, पर उसको समझ आ गई है, right, that's the power. This is very simple algorithms running for translation. जबकि ये modern जो large language models, transformers, जो कि deep neural networks का इस वक्त शहजादा है एक किस्म का, वो use हो रहा है वहाँ पे. So a third example of truly amazing things, आपने गूगल बलून का सुना है? नहीं सुना? सुना है? किस लिए बनाया था, किसी पता है? So some years ago, Google had this idea. There are several companies that are trying to bring universal internet coverage. एक हमारा दोस्त Elon Musk है. He's succeeding beyond everyone else. He is sending a lot of small satellites into space. Eventually, they will have thousands of satellites covering the whole Earth. Yes, and there will be internet connectivity everywhere. Sahara hai, Samandar hai. He is already providing to, I think, Ukraine and some others, जहाँ पे conventional infrastructure is destroyed. So that's the idea of a universal coverage. Yeah. So some years ago, Google had another idea to do that. Instead of going to space, they decided to go to the stratosphere. Their idea was stratosphere मतलब बादलों से ऊपर जो है. So their idea was that we will have these balloons flying around the world, especially in areas where there is no coverage, and they have in them base stations, small communication stations, which will provide internet connectivity. They will be connected to each other, and they will be providing connectivity to people below. और इनका फुटप्रिंट बहुत बड़ा होता है क्योंकि काफ़ी ऊपर होते हैं. ऑफकोर्स सैटेलाइट के इससे ज़्यादा होगा, बट दिस वाज एन इंटरेस्टिंग आइडिया. And to keep them there for several years, they had to make it very simple. इसके अंदर they could not put any special thrusters or anything. The only way this guy can navigate is by looking at the wind. उसको डेटा जा रहा होता है विंड का, इसके अंदर भी different sensors लगे हुए हैं. It can adjust its altitude a bit to make use of wind किधर जा रही है और मैं अब कैसे इस तरफ जा सकता हूँ. Yeah. Now, after some tests, the engineers were looking at the data. They were sending it to South America somewhere, and they saw that the balloon was taking a rather strange path. सीधा जाने की जाए ये कर. Yeah. And they hadn't programmed it. It's running on AI. It gets all the data of the winds in the region. It gets a target that you have to get from this area to this area, provide coverage, stay there for 2 days, and then return. Okay, or go to the other area like that. So they found that it was doing this thing. ये जो loops बना रहे हैं ना ऊपर, it was doing that thing, and they were perplexed. So they coded it to not do that. But then they looked at the data more carefully, and they realized that the balloon itself, the AI in there, had discovered an old technique used by sailors called tacking. In sailboat, ये motorboat नहीं है, motorboat तो किस way? Sailboat है. Wind is this way, coming this way. Is there any way you can go opposite to the wind? Sailboat है बात वाली, या मुश्किल होता है या तो बंद कर दें उनको इंतजार कर लें. So they were expecting that this will go, if the wind is in an opposite direction to where the balloon is supposed to go, it will go a bit higher or lower, where either it is more or less stationary or it's going in the right direction. But the balloon had a better idea. It stayed on fixed level in many places and used this technique of tacking. अपनी वो direction को angular बनाता था इस तरह कि it could go against the wind but in a zigzag kind of way. Now they hadn't programmed it. And the fact that it discovered or learned an old sailor technique जो अब we use करने की ज़रूरत नहीं है, we have motorboats and all that, was amazing itself. So again, it shows you the power of AI. This one, these are machine learning based problems scientists study. So they wanted to study, okay, what if we tell this is a robot, actual नहीं है, ये simulation में, and it is told that you have these 6 legs, but one of your leg is hurt, so you can only use it 10% of the time, and it has to find a gate. चाल इसने ऐसी ढूंढनी है जिसमें वो सिर्फ 10% use करे, using AI machine learning models. Okay. इसमें Every time it uses more than 10%, it is penalized. So it then realize, okay, my current solution wasn't good. So it keeps on iterating, trying to find this is reinforcement learning. We will see that later. Yeah. So that's fine. They saw that it was finding for the same problem, 10% front left leg. It would find many different ways of doing it. Yeah. एक यहाँ पे दिखाई. But things got interesting when the scientists or the people who were designing this decided to check this guy by saying that all 6 of your legs are hurt. ठीक है? और उनको बिल्कुल यूज नहीं करना. So they thought it will just stop where it is. 0 पे रुका रहेगा. क्या आपको क्या ख्याल है क्या करेगा? They are only giving it a target and kind of a punishment or reward for doing the right thing. That's all. कोई वो बता नहीं रहे करना कैसे. ठीक है? So the converged model, शायद कुछ models में खराब किया होगा, but the converged model that met the reward or penalty conditions was this guy. इसने क्या किया? इसको कहा तुम्हारी सारी legs खराब है, अब क्या करोगे? This is real stuff. आप you can go to their website. ये पेपर है बड़ा अच्छा. ये इसमें बहुत सी ऐसी एग्जांपल्स हैं. So और उसमें लिंक्स भी हैं फिर, right? So it realize okay मैं कोनियों पे चल लेता हूँ. Yeah. So again I am giving you truly remarkable examples. And this is showing in protein. I showed you last time theorems का जो knot theory है मैथ में related to topology and stuff. It's finding new knots, new links between knots जो हम humans को शायद time लगेगा ढूंढने में. So again, it's not just a curiosity for solving big problems. It's also something that can help us develop new intuitions, new understandings. As the human brain, last time मैंने दिखाया था आपको कि with all its powers it can go wrong. Yeah. So this guy also, interestingly, a neural network was trained and it was able to say at first with 57% confidence this is a panda. But then it was given this thing 0.007 multiplied by this, so इसका sum उसको feed किया गया. Or it said with 99% confidence that it's a gibbon. Gibbon monkey की एक variety है. Yeah. अब for you and me, there is no relation. ये क्या है ये? Right? But the thing is, the AI, the machine learning doesn't see images like that. इसको तो पांडा नजर नहीं आता. वो तो RGB ही देख रहा होता है ना, pixels की values देख रहा होता है, red, green, blue. So even something which is simple for us could become rather dangerous for AI. So when it messes up, it messes up big. ये challenges में से उसके शामिल है. Yeah. So of course we have to find ways of avoiding big mess ups. Yes. So anyway, that was the learning algorithm. Now notice when I first showed the slide, I had said how do machines learn? I had said they learn mostly algorithmic. The mostly word that needs attention. और कैसे सीख सकते? Trial and error. That would be an algorithm, right? So iteration is a trial and error thing also. So is there some other way we can teach devices or machines? आप में से कोई material science में? हाँ, आप बताएं. और भी है experience, right? So smart materials का सुना आपने? Smart memory alloys, shape memory alloys and memory materials, all those. So you can teach them through some physical property also. If this is a smart memory alloy, this wire is made up of a smart material, and you give it a shape and give it a current, and then just remove it, whenever its physical conditions change to whatever you want it to react to, it will return to this shape. Now this guy learned to come back to this shape whenever it was in liquid or water, but that wasn't algorithmic. इसमें कोई math तो use नहीं हुआ, yeah, algorithmic नहीं है ये. So that's what I meant by mostly algorithmically. Objects can learn in other ways, so don't limit yourself to algorithm. In fact, the future might be these guys with machine learning. Imagine क्या हो सकता है, और ये सिर्फ curiosity नहीं है. NASA is working on this. Imagine आप जो you want to make some station on Mars and you could उसको आप बिल्कुल फोल्ड करके रख दें, मार्स में जो ही वो पहुंचे तो प्रॉपर खुल के वो सेट हो जाए, right? So they are working on these kinds of things where you could fold things, make them compact, make them small, transport them, and then they unfold themselves in the right environment, in the right way. ये उसकी इसको इन्होंने ट्रेन किया हुआ है to take the shape of a paper clip, so whenever it's heated it comes back to paper clip, and this one is trained to be a spring. Whenever there is excessive heat वो वापस आ जाए. So learning is not limited to this thing, right? Any questions?
सर ये हमने algorithmically सीख सकते हैं सर. सर images अगर हम मशीन में images दे के उसमें फिट करें, फिर हम उसे image दे वो distinguish कर सकेगा.
Images दें.
Images के साथ train करें, algorithmically नहीं.
Training with images is algorithmic. The image will be converted into some sort of matrix, right? So for a machine, an image means कि एक point है, pixel है, right? So image is made up of pixels. Each pixel has 3 values at least: RGB, red, green, blue. Yes. So based on those values, you can always convert an image into a 3-dimensional matrix. Tensor बन जाता है. पहले matrix में the values of R, दूसरे में values of G, तीसरे values of B. Actually, that is what we feed to convolutional neural networks. Yeah. So yes, that is still algorithmic because it can be converted into numbers. And for me, the only example I could think of non-algorithmic was this one, जो कि actual physical properties से वो सीख रहा है. Yeah. Everything else for me was algorithmic. Any other questions? मैं 21 चेक करूँगा, अगला लेक्चर किस बार? तो अगला नेक्स्ट टाइम करें, क्या हिम्मत है? अगला टॉपिक है, बस होगी. अच्छा, तो फिलहाल है क्या अभी? और I'll just give you a trailer for what's coming next. We have seen magics of learning in things and algorithm and those things. So these are the 2 questions we'll be looking at next week, inshallah. Okay, at least these 2. There might be more. What makes machine learning so special and powerful? I've already given you lots of hints, yeah, but we'll make them more precise maybe. And have you seen example of mathematics that learns before? क्योंकि a lot of you are from mathematics, नहीं भी हैं तो किया तो होता है कि काफ़ी सारा math. So we will try to see कि पहले भी हमने कोई ऐसा math देखा है जो can fit into the idea of learning or not. Yeah. So, but I was originally planning to cover it today, but I think we can leave it for next time.